Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem, minimize XOR. This is a medium level question, and so now let's discuss their problem statement. So in this problem, we have to given two positive integer num1 and num2, and we have to find their positive integer x, and the condition of x is has the same number of set bits as num2, and the value of x XOR num1 is minimal, and after that we have to return the integer x. The test cases are generated such that x is uniquely determined. So now let's discuss their problem statement, and after that we have to look their example test cases. So now let's discuss this. So first we have to given a num1 and num2, and we have to find their x value. Okay, so first we have to given a like the same number of set bits, like the binary representation of x should have the same number of ones bit, and this ones bit is a set bit. And the second scenario is minimal XOR. These are both two conditions we have to give, and the minimal XOR condition is the result of x XOR num1 should be as small as possible. So these are conditions we have to given here, and now the key idea of this problem is the key idea. So first we have to represent their binary representation. We have to look in there, like the number can be represented as a series of bits like 0 and 1s, and this one bit, this is our set bit, and we have to take care of only one bit. And the second thing we have to given here, the XOR operations. These XOR operations we have to perform. Okay, and so now the four condition we have to look here. 1 XOR 1 is equal to 0, 0 XOR 0 is equal to 0, 1 XOR 0 is equal to 1, and 0 XOR 1 is equal to 1. And so these conditions we have to follow up. And so now our goal is to construct x and such that it minimize the result of x XOR num1 while ensuring the number of set bits in x equals the number of set bit in num2. So these are our goal, like if x XOR num1 we have to perform, after this we have to find their set bits is equal to their num2. And so now let's discuss their example test cases. So this is our example 1. So in this example we have given here num1 is equal to 3, and the second thing num2 is equal to 5. So now the binary representation of both the numbers, the binary representation of 3 is 0 0 1 1, and this 5 is 0 1 0 1. Okay, and so here we have given here it 2 bits are set, and same for this 2 bits are set bits, and like this one 1 bit 1 where the 1 is present, this is our set bit. And now we have to, this is our step 1, and the second step we have to required x. The x must have must have two set bits because the num2 has two set bits. Okay, so now the third thing is, now we have to find the possible set bits where two set bits is present at a time. Like if the binary representation of 0 1 2 3 4 5 6 7 8 and 9. Okay, and this one, so the 0 representation of this is 0, and 1 is this one, and 2 is this one, and 3, now 3 representation of this is this, and the 4 representation of like this, and the 5 representation of this is like this, and the 6 representation of this, and the 7 is the 4 5 6 7, and the 8 representation of like this, and so 9 representation of our bit is this one. So now here we are getting like where two set bits are present, the 3 and the 5 and the 6 and the 9, which is like x is equal to 3, x is equal to 5, x is equal to 6, and x is equal to 9. These are our possible values which we have to present on this scenario, like where two set bits is present. Okay, and now and so on, we have to find their values, like we have to calculate only for these values, and we have to get their minimal values. And then after minimizing JOR value, we have JOR with the num1, and JOR with num1 we have to calculate with all these values, like 1 second, we have here calculate with num1 value is 0 0 1 1 0 0 1 1. Okay, and so now JOR with this one is the same number and this value, these bits are 0 0 1 1, and when we are using the same bits, like here same bits JOR is always 0. Okay, same bits JOR we have always 0, so that's why like this one, this is our num1, and this is our x value is equal to 3. So now we have getting here 0 0 0 0, and this is 0, and same thing for we have calculated with x is equal to 5, x is equal to 5 value is 0 1 0 1 0 1 0 1, and for num1 sorry, we have here 0 0 1 1, and whenever we are same bit, this is 0, this is 1, this is 1, and this is 0, and this is also be representation of this one 6. Okay, this is representation of 6, and now let calculate with their value of num1 and x is equal to 6. We have to get in here this 6, and the num1 value is 0 0 1 1, and the XOR x value of 6 is 0 1 1 0 0 1 1 0. And now this is 1, this is 0, this is 1, and this is 0. The representation of this is 5, and the last one is our 9. The 9 is num1 and x is equal to 9, and the value of this one is num1 value is 0 0 1 1, and 9 value is 1 0 0 1 1 0 0 1, and this is become 0, this become 1, and this become 0, and this become 1. And this representation, the representation of this one is like 8, this is representation of 11. So now the minimum XOR is achieved by x is equal to 3 value. X is equal to this one, because we have to get in here 0. So this is our minimal value we have to getting here. Like, now let's discuss there on a table form. Like, so our possible x value here, and the binary representation of this one is here, and the set bit is here, and now XOR value is here, and the XOR result is here. Okay, so now 1 second. So this value is, sorry, 10. This is for 10. Okay, and so now let's fill this for line by line, like 3 5 6 and 9. So you have to represent their values here. Binary representation are here, and now set bits are here. How many set bits are present there? Both are two set bits. And so third thing is, we have to XOR with which value, like 3 XOR 3 we have to calculate, and like here 6, sorry, 5 XOR 3, here 6 XOR 3, and here 9 XOR 3. And the XOR value are getting which value we have to getting here, like 3 XOR 3 0, 5 XOR 3 we have to get here 6, here 5, here 10. So these are our values, and the minimum value we have to present here is 0. So the answer is equal to 0. No, sorry, the answer is equal to 3. So answer is equal to 3. So I hope you understand the logic behind that, um, how we find their minimal value, and after representation how we achieve these values. So so the same condition we have to perform for example 2. And so now let's uh, let's discuss their code implementation part. 1 second. So this one. So here yeah, so first we have to using with bit this bit with built-in pop count. This is a function in C++. So it counts the number of ones set bit with the binary representation of num2. Okay, binary representation of num2, and we have their answer variable to how to find their minimum values. And after this we have their values, like we have to iterate with our loop with 31 time. Okay, with reverse order and last to first, and it iterates over 32 bits from the MSB, most significant bit, and this is the 31, at least 31 to their significant bit of 0. and now we have to calculating their mask value. This mask, we have to create the mask with ith bit by left shifting of 1 by I. Okay, 1 by I, and this is the bit we have to shift there. And now let's explain this one, like how this performing. And first, let's suppose we have there I is equal to 2 and the mask is equal to 1 left shift is 2 is equal to, like, the binary representation of this one is basically we have to get in here 4 and the binary representation of 0 0 0. Okay, so and this is our values we have to performing here. And after that we have here the if mask and num1. This mask and num1 is like to check, it is to check the ith bit of num1 is set. Okay, and the mask of num1 returns, it returns non-zero if the non-zero value if the ith bit of n1 is 1. So these are their values we have to find here. So after this we have there here, like here we have to create to store our all these values, all these masks. Like we have to add the ith bit to answer by setting it answer plus the operations we have to perform. And after this we have to decrease their values, like bit minus minus, like bit minus minus is because we have to require the set bit has been placed is our exact position of their answer. Okay, and after that we have their bit is equal to 0 and it requires the set bit of has been placed in exit loop. The same thing we have to perform here. And now the bit is equal to 0 is if no more set bits are required after the first loop, after this loop. And so that's why we are using this one. And now after that we have their start to their 0 to their 31 30th time we have to iterate this one. And now this one is iterate with their least significant bit. We have to find LSB here, and the mask is here to, we have to calculate their mask. We have to also uh, calculate this value before. So I hope you understand the mask is equal to 1 left shift of I. So and after that we have the same operation we have to performing here, and so directly we have to return their answer. So now let's discuss their time complexity and space complexity. So the time complexity of this question is the time complexity. The first loop we have to iterate with 32 bits, and this is also be O of 32 time. And the second loop we have to iterate with their 31 time, and this also be performing O of 31 time. So the total time complexity of this one is O of 32 plus O of 31 is equal to O of 1. This is our constant time, and this is a optimal solution for this problem. And this is our space complexity. The space complexity is this question is we have only uh, a constant amount of extra space, like variables, like we have to declare bits, answer, mask. So the space complexity of this question is O of